For more than 50 years, FHWA, the Federal Highway Administration, has been providing technical assistance to its transportation counterparts overseas. Recently, efforts have been stepped up to make worldwide technology exchange activities a two-way street. This new thrust toward global outreach is led by FHWA's Office of International Programs under a mandate by Congress to inform the domestic transportation community of innovations that could significantly improve highway transport in the United States. The National Cooperative Highway Research Program and AASHTO, the American Association of State Highway and Transportation Officials, and its Special Committee on International Activity Coordination are partners in the effort. One of the greatest successes to come out of this partnership is the International Technology Scanning Program, which brings back to the United States usable ideas from abroad. The scanning program looks for advances in technology, management practices, and research that can be cost-effectively adapted to U.S. federal, state, and local highway programs. Scanning review trips are taken by teams of specialists to consult with foreign experts in the same field. The teams are made up of representatives from FHWA, state highway departments, transportation trade and research groups, the private sector, and academia. Instead of reinventing the wheel, the scanning program enables existing advanced technology to be put into practice more quickly and makes more efficient use of research funds.
Each country has worked on various components of the transportation system, those pieces that are important to them. And as they've focused on those, I believe that they have found, in many cases, better ways to do some things. And I think the real value is that we can learn those things and bring them back to ourselves and move the innovation forward faster for our own people in this country.
Since the scanning program was launched in 1990, more than 25 sophisticated reviews on various surface transportation issues have been completed. Many of the ideas have been implemented on American roads or are in the process of being evaluated for use. The first European scanning trip in 1990 has led to nationwide use of SMA, stone matrix asphalt, a major advancement in road paving materials. Now, several states routinely use SMA. Maryland has placed more than 1.3 million tons of stone matrix asphalt, and Georgia has used 950,000 tons of the rut-resistant mix. SMA has proven to last several years longer on high-traffic roadways than conventional mixes, and in life cycle cost studies promises significant savings over traditional asphalt.
About 5 years ago, I participated in an international trip dealing with intelligent transportation systems. And we visited a number of European countries and saw some really phenomenal things they were doing. And we took along people from various states within my region of the country. And I find that much of what we saw is actually in place today. And that's really proof that this technique really does work.
A company in California participated in a scanning trip to Europe and Japan to investigate the use of composites in bridging. Exis Technologies uses composites for the repair and retrofit of bridges and other structures. The company brought back a technology from the scanning tour that saves time and therefore money on each job by speeding up the preparation process before a composite repair is made.
By gaining information of state-of-the-art technology, it helps us improve our products. We don't have to reinvent the wheel and take the state-of-the-art technology and improve it from our point of view, and by doing that, we will give our customers a better service.
A scanning trip across Europe and Japan inspired several states to form a consortium with the goal of designing and building snow removal equipment using ITS, Intelligent Transportation Systems. In Japan, data on weather and pavement conditions on expressways is collected by a vehicle that is both automated and intelligent. Working from a traffic management center, the Japanese get real-time information from the data vehicle on amount of traffic, its speeds, and the pavement conditions. The efforts of the data-gathering vehicle culminates with the dispatching of state-of-the-art maintenance equipment. In the United States, detailed information about road conditions is critical to the 38 snowbelt states. Based on the findings of the Japanese scanning tour, the Departments of Transportation of Iowa, Michigan, and Minnesota joined forces with private companies to develop similar technology. The outcome is a concept vehicle that delivers both detailed road conditions and provides the latest ITS technologies to maintain roads during winter storms. The Japanese scanning trip was taken in 1994, and just 3 years later, each consortium state had a new tandem axle truck equipped with snow and ice control equipment, an air and pavement surface temperature sensing device, a pavement friction measuring device, and a global positioning system receiver. While some scanning trips have been the basis for creation of new equipment and systems, others have been the inspiration for changes in construction materials. Because of the heavy amounts of salt used to keep the roads clear during the winter, steel in bridges is more vulnerable to corrosion. Based on the information obtained on a European bridge structure scanning review, the Minnesota DOT, along with the City of St. Paul, has modified 2 bridge projects. Engineers replaced the galvanized steel slab tendon conduits with polyethylene on the $25 million Wabasha Street Bridge in downtown St. Paul. A similar system using polyethylene is slated for the $60 million St. Croix River Bridge. It's hoped that the enhanced corrosion protection gained from the polyethylene will save money in the long-term maintenance costs and upkeep of the bridges as it has in Europe. In addition to scanning tours, the Federal Highway Administration encourages participation in conferences and professional society meetings as resources for tapping international transportation expertise. Organizations such as the International Road Federation, ITS America, and the World Road Association hold expositions in which state-of-the-art global technologies are displayed. As ideas for transportation innovations are generated from conferences and from scanning tours, the challenge is to effectively transfer information out to states and local transportation agencies, which can put new practices into use. AASHTO's Special Committee on International Activity Coordination plays a key role in this information-sharing objective. The committee's chief interest is international technology transfer, using its 26 members from several states to accomplish its goal.
The subcommittees of AASHTO are all represented so that they can take it back to their committee and share it with all their counterparts, whether it's construction, maintenance, or ITS, or whatever the topic may be, that we'll get it back to those states.
More communities will benefit as they have greater access to new ideas. The city of Phoenix participated in a 4-nation scanning trip covering pedestrian and bicycle facilities. As an outgrowth of that tour, Phoenix has adopted an aggressive program to add more bike facilities and make streets more bicycle and pedestrian friendly. All new major roadways in Phoenix will have on-street bike lanes, and all sidewalks will have a buffer between them and the auto traffic. Phoenix is also using traffic calming methods similar to the orange and white plastic barriers used in London's traffic calming program. One Phoenix street used to have more than 2,000 vehicles per day due to cut-through traffic. Using a temporary diverter, the same street now experiences an 80% reduction in traffic. Plans are being made to replace the barricades with a permanent landscape diverter. An international contract administration scan resulted in innovative contracting now being practiced in several states. Using scanning tours, an array of transportation ideas can be brought back from around the world.
We want to try to advance the state-of-the-art, state-of-the-practice in areas we've worked on in the past, like pavements and structures. But more importantly, to open us up to areas that we've never had experience. And some of the institutional and policy changes that are taking place in countries worldwide really give us opportunities. Innovative contracting, private toll concessions are a couple of those examples where we're looking at it and about to get into it in the United States and getting into it in a little bit in a few states. But there's far more experience outside of the United States, and that's where we can learn.
Disseminating ideas like these is the goal of AASHTO's Special Committee on International Activity Coordination, which will use several methods to encourage wider use of new technologies.
I think at least that it's going to be printed communications. I think it's going to be use of the internet and ways of getting information out in new ways there. I think it's going to be workshops, and we've had a number of those. The Federal Highway Administration, for example, has sponsored workshops in SMA and in the concrete techniques that we learned overseas. And various kinds of things will have to be used. But we need to ask each committee, the bridge committee, the pavement people, the maintenance people, what will work best for you?
With 4 million miles of roads and 550,000 bridges across the United States, there is a need to remain technologically and economically competitive. International technology transfer is helping to achieve this objective. Global outreach has inspired demonstration projects and transportation techniques that are already being used to create better roads for the American traveler.